Hello. Hello, everyone. Welcome here. Thanks for being here. My name is Juan Arruti. I'm a support engineer at Percona. I've been there in Percona for 7 years, and today I will share my experience about troubleshooting the Percona operators. This is the agenda. Before to start with the troubleshooting part, I would like to introduce the operator concept. Operator is basically an extension for Kubernetes, which has a resource type, which is called custom resource definition. And that custom resource definition represents a specific application objects and configuration. The operator is a higher level of abstraction, since you have to only interact with the application, in this case the database, and since all the other operational features were already automated. It says, again, automates the management of complex workloads by specifying an application behavior, and it's useful in particular for stateful applications. You know, they are more complex, right? You know, they have a PVC, a persistent storage, so you need to take care about the backups, failover, and so on. Then we have the Percona Kubernetes operators. Actually, we have 4 of them, 4 flavors. Automates the deployment and management of the databases. It's open source. It is free from vendor lock-in. This means there aren't limitations for implementing in a cloud provider, in any cloud provider or on premises. And they have enterprise features like backup restore, HA, replication, and login. Okay. The first flavor is the Percona operator for ExtraDB cluster, which is a MySQL solution based on Galera replication. It is virtual synchronous replication. There is no single point of failure. It has load balancing and proxy with either HA proxy or proxy SQL. You can select one of those. It has automated or manual backups provided by the Extra Backup tool, and it's integrated with the Percona Monitoring and Management tool. Okay. Then we have the Percona operator for MySQL. This is also MySQL compatible, but it's based on the group replication or asynchronous replication technologies. For the replication management, you have the orchestrator, HA proxy for load balancing, and MySQL router is done by when you have the group replication option. The same, automated backups and manual backups are provided by Extra Backup, integrated with PMM for monitoring. This one in particular is in test preview, so this means it is available for testing, but it's not ready for production. If you are looking for a MySQL compatible solution, you should go with the PXC. And then we have the Percona operator for MongoDB, which is a MongoDB solution for Kubernetes. HA is provided by replica sets. It has sharding support, automated and manual backups provided by the Percona backup for MongoDB tool, and it's integrated with PMM as well. And lastly, we have the Percona operator for the Postgres SQL. This one is a fork from the Crunchy Data project, has HA with Patroni, supports asynchronous and synchronous replication. PC Bouncer tool is used for the connection pooler, and PC Backrest for backup and restore utility, right? And it is also integrated with PMM. So these are the solutions that we have for operators, right? Kubernetes operators. Okay, let's talk about troubleshooting the operators. Basically, the issue with Kubernetes and the operator is that you have a new level of abstraction, right? So sometimes it's hard to distinguish which particular issue is coming from the Kubernetes side or from the application side. So with my experience, I tend to detect these issues based on the pod status, right? Pods are the smallest unit in Kubernetes. It's a group of containers, can be one container or a group of containers. And when it fails, it's manifested in the status column. Okay, you can get the pod status, but queue control get pods. Okay, this is the first state, which is running, which there are no issues there. You can see the status column there. And the age indicates when the pod enters in the running state. You can see there the H proxy like 2 hours, and the PXE almost 1 hour. So there aren't issues there, right? This is a particular issue from the Kubernetes side, right? Image pullback off. When you have this issue, the Kubernetes is unable to pull the image. It can be, the reasons can be many. For example, invalid image name, image of phone. Maybe you have a container inside in your company and you can't, and the cluster can't access it, or you have networking issues, right? I left there the Percona certified image page. In case you are in doubt, you can go there and find the certified image for each operator, right? Image pullback off, you can see the status there. This is an example. This particular issue is really clear. It manifested there in the status column. You can see 3 out of 4 containers ready, so there is 1 failing. And you can see in the age column says 22 seconds, so this issue happened recently. Right? It's really easy to troubleshoot. So, but how to troubleshoot it further? You have the command queue control describe pod, which gives you detailed information about the pod, its pod metadata, including the image name, container status, and list of recent related events. You can see an example there, the kube control describe pod. At the bottom, you can see all the related events, and you have the error there, image pullback off. In the next line, you have the name of the image that is trying to pull, right? Wrong image. And that's it, really straightforward to troubleshoot and to fix it. Pending. Pending per se is not an issue, but what happens if pending is actually when the Kubernetes is scheduling, is time spent scheduling the pod. But what happens if a particular pod is in that state for, like there in the example, for 8 minutes, right? That becomes an issue, you know? Something is stuck there. You can see the status pending, 0 out of 4 containers ready, and you can see there it happened like almost 9 minutes in that state. So you have there an issue, you should troubleshoot it. It won't be fixed automatically, right? So, result from pending stacks. You have, this is a really common issue, insufficient resources, mostly CPU and memory. You can see in the example, in kube control describe pod, there is a container sections that shows the request, the memory request, says there are 50 gigs. And in the bottom of the event, you can find the actual issue, warning, and it failed scheduling, and you can see there insufficient memory. This means that the worker node does not have enough memory to schedule this particular pod, right? There are other reasons for pending stack, like scheduling conflicts. These are particular when a pod fails one requirement. most likely related with selectors, taint, and tolerations. In this case, you can see the kube control describe pod. It says that the pod had an untolerated taint, which is up node DB. That taint is from the worker node. You need a toleration to be scheduled on that particular worker node. And you can see there in the section tolerations that the pod does not have this particular toleration, right? So also it's really easy to fix. Okay, this one is a bit more tricky, right? Out of memory kill. Probably you already know from Linux, right? When a process does not have when the system does not have enough memory, and a particular process reach a level of memory allocation, the out-of-memory kill is triggered and kills the process. In this case, it's the same, only that the pod is killed, right? It's a mechanism to reclaim memory. In Kubernetes, a process triggers out-of-memory kill due to if you reach the container memory limit. Let's say you have 50 gigs for a pod in particular, and your process inside the pod allocates more than 50 gigs, it will be terminated, right? Also, another situation is when you have a resource quota at namespace level. If all the pods shared in that particular namespace reach that quota, the pod consuming more memory will eventually be killed, right? And the last one is when the worker node does not have enough memory, right? Is starving on memory, the same, you know, the most consuming memory pod will be evicted. Okay, debugging out-of-memory kill, as I say, it's a bit tricky because you can control when it happens, right? You don't know when it will happen, and the state remains there in the kube control get pod for seconds because the pod is restarted, and then when you get there, probably the pod is in the running state, right? So in this case, you can see there auto-memory kill. Auto-memory kill. As I said, it's hard to catch this one with the kube control get pods. But if you go to kube control describe pod, you can see the previous restart reason, right? And it's there. Last state terminated, a reason out-of-memory kill, right? And it also shows the date it was finished, and also shows the container memory limit. Okay? But there are some cases that the pod can enter in a state being killed, forcibly killed the first time, but out-of-memory kill, and then restarts, and then it's in a state, inconsistent state, and it goes in a crash loop back off state. Well, in those cases, it's a bit harder to troubleshoot. So there is another option, which is using the kube control debug command, which creates an interactive shell on the underlying worker node, right? So running kube control debug, you need to find the node where the pod is running. You execute kube control get pods -o wide, and you will get the pod name, the worker node name, sorry. And you create there, on that particular worker node, you create an interactive shell with the kube control debug command. And that will mount the worker node file system on the /host. And from there, you can check the kernel ring buffer, and you can execute the message -T, capital T, and you can find that information. Bear in mind, when you create this pod, the pod is not privileged. So the kernel, the dmessage underscore restrict, must be disabled to see this information, right? So we have here a kube control debug example. I execute the kube control get pods -o wide, that shows the node name. And then I executed kube control debug on that particular node with the Ubuntu image. That mounts all the worker node file system into this particular pod, and then you can see the kernel ring buffer, right? Executing the message -t. You can see there memory is a group out of memory, killed process, MySQLD, and you have information about the total memory that was, the resident memory, and the file system memory there. Okay, this one is really good to troubleshoot these issues. Okay, reducing the dash memory. Usually this happens in the MySQL pods because MySQL by default needs more, takes more advantage from the buffer pool, from the cache, right? So by default, the InnoDB buffer pool is set by like 3/4 of the container memory limit, right? So that doesn't happen on the MongoDB and the Postgres operators. It's only 50%. So it's not, it happens, but not as frequent as with the MySQL operators. So to solve this, you can overwrite the InnoDB buffer pool size in the YAML file. You can deploy the CR YAML file and put there the InnoDB buffer pool to a lower value. And you can also save file system cache by setting the InnoDB flash method equals to outDirect. With this, with InnoDB flash method outDirect, you avoid double buffering, right? Using the MySQLD process memory, and at the same time, the OS caching the data files in the OS, right? So it will only use the InnoDB buffer pool for that matter, okay? Okay, these were the most common issues that we have at support from the Kubernetes side, right? These issues are mostly from Kubernetes side. It's not really related with the database. But what happens when the database fails? How we can detect them and troubleshoot it? Okay, so the way it manifests the issue when it's failing from the database side, from the application side, is the crash loop backoff state. It's a pod state, and it's a restart loop due to application crash. The application start, or it was running, it suddenly crashed for some reason, and it goes in a state that it crashed and it crashed and it crashed. You need to manually fix it, right? There are exponential delays between restarts. Usually this is caused by failure in the readiness probe or the liveness probe proofs. Crash loop backoff. You can see there, and the status column. And the restarts column, you can see that it crashed like 4 times in 5 minutes. So that won't get better, right? You have to do something you have to interact with the operator to fix that particular issue, right? So readiness probe, liveness probe. Readiness probe indicates if a container is ready to respond to request, and the liveness probe determines if a container is healthy. If it fails, the pod is terminated. So this is the way that the kubelet has to detect a particular application is no longer part or is no longer healthy in a cluster, right? It's a custom script for each operator. Actually, it connects to the database and checks the state of the node, if it's part of the primary. If it is not, deletes the pod, okay? So you can see there in the kube control describe pod, you can see in the container section, you can see the liveness and the readiness script and the option it has. All these options, you can customize it in case you have larger, or if your database is larger or a bit smaller, you can tune further these options. Okay, so proof failures, possible causes with databases. Wrong database configuration. Actually, MySQL, if you have an option that is not valid, it will try to start. It will find that there is an option that is not valid. It will report an error. I will go down, and it will make the pod to restart. The pod will do the same, and then you have the same issue. You know. So another issue is the network. For example, in a cluster, you can join a particular cluster. So the pod is not part of the primary state. It goes out of the cluster. Bugs, that's another option. Signal 6, signal 11. When it is running, when it is starting, that can cause a particular pod to be evicted from the cluster. Performance as well. You know, some particular node is having issues, disk issues, CPU issues, whatever, and the node, the pod that is on top of it, it's a bit slow, and eventually that particular pod may be evicted from the cluster. Okay, so it's outside of the cluster, then it goes the proof fails, and restart the pod. And the last one, which is really common, to be honest, no available disk space. When MySQL or another program cannot write to a file, cannot write to the binlog file, abort its execution. Okay, so these one are the most common issues. So how to detect them? You have to check the events at the bottom of kubectl describe pod. It shows there the reason unhealthy. You can see there it's from the kubelet. The kubelet is the one in charge of doing this operation to take care of all the pods are healthy. And the message is the RNS proof failed, AYD failed, because it was not able to connect to the MySQL server. Okay? And a way to troubleshoot further this issue, you have to go to the application logs and to review the logs of the MySQL database or the application. Okay? So in this case, you can see kubectl logs, the unknown variable there. This is extract from the MySQL, from the kubectl logs, but it shows it sends the MySQL error log to the logs container, and you can see there it's just error unknown variable, and then it does not start, aborts there. Okay. Any question so far? Sure. The issue with the out-of-memory kill that it aborts it kills -9. No, on the application log you won't have anything. It will be like nothing was written anymore, and then it starts the database.
So this log is just from the application.
That's from MySQL. That's from MySQL, but it's a ROM variable. It's not related with out-of-memory kill. It's more related with Kubernetes.
I'm just saying, so you have applications that will sit.
Yes. No, out-of-memory. Yeah, that is true. Out-of-memory won't be displayed there. That's why it is hard to catch. It's a kill-9, so the application, the process does not have time to write, I'm shutting down. Yes, on the underline, as we saw, on the underline, no, you have in the kernel ring buffer, the message command, you have that information there, the out of memory killer activity. Okay. Any other? Sure. There is a section on the XAML file which is related to the storage, and from there you set the amount of disk you want to allocate. Okay, and from there the operator automatically will allocate that in the persistent volume claim. You don't have to do anything. That's the magic of the operator, right? No problem. Okay, recovery scenarios. There are some particular scenarios when you want to manually debug the system or stop it, or graceful stop, you know, to stop and then start from scratch, or maybe want to debug a particular image. So let's say for example, nowadays it's not really common, but in the previous versions, for example, if there is a mismatch in the secret file, right, that use the operator to access MySQL to check if it's healthy, if there is a mismatch in the secret file and the actual password that MySQL has, the operator won't be able to connect, and it fails, right? The kubelet can access the database, and it fails, and it fails, and it fails. So you need a way to stop this, you know. So there are mechanisms to do this and to prevent this loop failure, right? One scenario is pausing the cluster. You will stop all the pods in the cluster. This is usually related. You do this when there are maintenance tasks, Kubernetes related maintenance tasks, when there are configuration changes, MySQL configuration changes. For example, if you have to enable or disable SSL on MySQL, on PXE actually, you can't, if you have, for example, let's say you have SSL and you want to disable for some reason, you can't do this in a rolling fashion. You have to stop all the nodes and change the configuration and start them. So for this particular case, it works. And then, as I said, if you need a graceful shutdown, performance issues or something like that, I don't recommend it, you know, I recommend troubleshooting the performance issues, but sometimes it happens that you want to shut down the cluster and start it again. You can do it with the pause option, right? You have to set to true the pause key in the CR YAML file, which is there, right? You apply the change, and all the cluster pods will be stopped, gracefully stopped, okay? And when the process is over, you only will see the operator pod running there, okay? So you did the change, and then you want to resume this and start the cluster again. You set to false the pause key and apply the change. Okay? Really straightforward. Another scenario is switching to debug images. The debug image is a different image. It has more tools on it, and also it does not fail the liveness check and the readiness check. No matter what happens with the MySQL process, it won't fail. The MySQL process will fail, but the pod won't be restarted, right? So then MySQL file, you enter there and you troubleshoot the issue. So as I say, avoid the restart on fail loop. You need to manually start the database. As I say, this is a clear example. There is a mismatch between the secret files and the database password. To avoid the proof failure, you put this image, you swap to the debug images, you manually start the database, you access the database as root, and then you change the operator password, right? Then you shut down, switch to the regular images, and then start the cluster again. As I said, if you need additional tools for debugging, it has Telnet, GDB, debug symbols, and the Percona toolkit. Right? This debug images is available for PXE, for the PXE and the MongoDB operator. And switching is really straightforward, to be honest. You have to add the -debug suffix to the image name. You can see there in the PXE section, you have the image, you add the -debug, and that will restart the pods. Kubernetes will pull the new image. The image is a bit larger than regular image. It will take more time to pull it, but in the end, the pod will restart with this new image. And then you can access the database container running kubectl execute -it. There is an alternative to avoid the restart on fail. It is only available for the PXE pod. You can do this with a regular image, so you don't have to swap to debug image with this approach. Prevents proof failures, so the readiness check and the liveness check won't fail. It's as easy as creating the sleep forever file inside the data directory, right? You can see the command there, kubectl execute -it, and you touch the sleep forever file. If the PXE container does not start, you can use the log containers, which mounts the same data, the same PVC on it. So you create the file by running kubectl execute, okay, and touching the sleep forever file. That will prevent the pod in going in a restart loop, and you can enter there and manually start it or debug it if you want. Okay. Any question about this? No. Straightforward, right? Collecting data. Well, these are the manual data collection, the commands that you usually execute to collect that data. kubectl get pods to list all pods, including their current state and availability. kubectl describe pod provides detailed information of including status and event, as we saw. This one is really useful. kubectl logs to fetch the application log or the database log. Right? kubectl execute to open an interactive shell and enter the container. And kubectl get services to display information about the IP addresses and exposed servers. You usually don't want to do this. You need a tool, right, to automatically. You probably have too many pods, and you want to see all the logs to troubleshoot, right, in a proper way. So you need a tool. By default, Kubernetes give you the kubectl cluster info dump, which dumps the cluster configuration, including the API server and the etcd database. You get the cluster logs, including kubesystem, and selected namespaces, cluster state, and cluster networking information, such as DNS configuration. As you can see, this one in particular, this command is more for troubleshooting the Kubernetes side. You know, for example, you have a DNS issue, the core DNS is not working, or some pod is not reaching the core DNS. You use the kubectl cluster info dump command to collect all the information. Provides a cluster activity view, as I said, useful when troubleshooting complex issues related to a Kubernetes cluster. And here you have the examples. You can send it with the output directory. You can send it to a file, or you can also collect all the namespaces. Or if you want, with the namespaces flag, you can collect one particular namespace information. Right? There is another tool that we developed at Percona, which is the PT Kubernetes debug collector, which collects cluster debug data such as logs, resource status, and events. And all the information is packed into a tar file, and it's part of the Percona toolkit. So you install the Percona toolkit, you will have this tool to debug to collect all the information to debug the operator. And the difference with the previous command is that it's the aim or it's targeted to collect operator data, right? Here we can see the flags. You can collect a specific information from a cluster, from a database cluster, right? namespace, collect the information from a namespace. Resource, this one is useful in particular to collect more information about in case, for example, let's say you are using the PXC operator, it will collect logs from the PXC containers, right? Here there is an example of the collected files done by the resource flag PXC equals PXC and collects information from the custom resource definitions, Percona XtraDB cluster, backup, restores. It also collects PT MySQL summary, which is a tool that we use at support to collect this information from the database, status variables, and configuration variables, right? And then individual files collect as well, like the MySQL error log, which is really useful for troubleshooting purposes. Actually, the one that is streamed to the logs container is in JSON. This one is the native MySQL error log. So it's, for me, at least for me, it's easier to read this file, right? And then if you are troubleshooting state transfer issues, you have the DynaDB backup tool or the DynaDB backup log and the prepare log as well, right? And finally, we have monitoring Kubernetes databases with PMM. This actually is my favorite part, to be honest, because in a few minutes you can have a fully functional cluster with monitoring enabled. So it's really quite cool. Okay, so Percona Monitoring and Management is an open source monitoring software. It has monitoring capability for databases, including MySQL, Postgres, MongoDB, and ProxySQL. It has query analytics to identify and optimize slow or inefficient queries. And the last version, 2.37, I think, it is bundled with new experimental dashboards for Kubernetes monitoring. So it gives you the cluster summary, pod status, and volumes, so which is really interesting. To monitor an operator, you need first a PMM server. Now in Kubernetes, you can install it with Helm. Helm is a package manager for Kubernetes. It's really easy to install PMM with Helm. First, you have to set up the admin password with this command. In the end, you set the admin password, which is an echo from the base64 command. And then you can install the PMM using Helm repo at the Percona repo, and then Helm install PMM and the Percona PMM, and you will have a PMM server running in your environment. And then once you have this, you go to the operator and connect the operator with the PMM server. First of all, you have to install the PMM client on the operator. You acquire the API key from your PMM server. You go to configuration, API keys, and add API key. You copy that API key, and then you go to the client, to the operator, and patch its secret, right? You execute the kubectl patch secret, and add in PMM server key, you add this particular key, okay? Once it's done, you have to enable PMM in the cluster, the CR file, and apply it. You go to the PMM section and change enable to true. You set the image version there for the PMM client, and you point the server host to the PMM service, the PMM exposed service, right? Kubernetes exposed service, like that. Okay, and then you apply that change, and each pod will restart. It will be a rolling restart, and they will have one container more, which is the PMM client, right? And if there is any issue, you can debug the PMM client using the kubectl logs, the pod name, -c, which is from container, and the PM client. And that's it. After that, you have a fully functional cluster with PMM, with monitoring enabled. Okay, that was the last slide.